Okay, John, so here is the second type of question that you're going to see when you're dealing with double and, not double, sum and difference of two angles. So the first type of question, so easy, we just did like 4 or 5 of them within like a minute. It's literally just you playing the matching game, looking on your reference sheet, and figuring out which one goes with which. Actually, what I'm going to do right now is go on Google, just in case you haven't done this yet, and I'm going to type in algebra to Trig reference sheet, and then just pull one of those up so that we have it next to each other, or it next to the screen while I'm doing this. Okay, so this is the section, this is your region or your reference sheet. This is the section that you want to be looking at right now, the sum and difference of two angles. So I'm going to have this up right here while we are doing these questions. Okay, so there we go. Perfect. Awesome. If sine x is 3/5 and cosine of y is 5/13, and x and y are positive acute angles. Now the reason why they're telling you that is because that means that both these angles are in the first quadrant, so that's important to know. Find cosine x plus y. This is the second and harder type of question that you're going to be asked to complete. These were the questions that kids kind of got a little bit confused on, but I really promise you that it's not that big of a deal at all. So we're trying to find cosine of x plus y. So the first thing that I'm going to do is look on my reference sheet and figure out what formula I'm going to need to find cosine of x plus y. So I'm going to look over here. It's the sum of two angles. So I'm looking at cosine of a plus b. So that equation, they use a and b. I'm just going to use x and y just because of the question that we're dealing with. Cosine of x plus y is equal to cosine a, or cosine x, cosine y, minus sine x, sine y. Okay, so far we've already been given two pieces of information. Now what the kids were getting confused with is we've been given the sine of x and the cosine of y. So let's fill in what we already know. We have been given the sine of x, so all the way over here, the sine of x is 3/5. And the cosine of y, which is 5/13. So I still need to find what the cosine of x is and what the sine of y is. So here's what I want you to do. We're going to come down here, and on your sheet of paper, what I want you to do is draw two separate triangles. Give yourself enough space. You're going to draw this triangle and another one. So we're dealing with two different angles. So instead of theta, this one's going to be our x and this one's going to be our y. Or actually, even better. We're going to do all of our x values in green and all of our y values in blue. The only reason why I'm doing that is to help you keep them straight, but obviously you can just use a pencil. So we know that the sine of x is 3/5. So the sine is opposite over hypotenuse. Okay, so sine of x is 3/5. So opposite over hypotenuse. We're going to use that triangle to figure out what the adjacent side is so that we can plug this in for the cosine of x, because cosine is adjacent over hypotenuse. So this is going to be something over 5. Now, actually, luckily, this is a really easy one because this is one of those triangle identities that we can remember really quickly, 3, 4, 5. I don't even have to use the Pythagorean theorem. 3 squared plus 4 squared gives me 5 squared. So I know that cosine of x is adjacent over hypotenuse, which is 4/5. Now I'm going to come over here to my other triangle. It gave me this information that the cosine of y is 5/13. So cosine is adjacent over hypotenuse. And you know what? This one might be another one of those identities that we can remember, but I'm not positive, so I'm going to use the Pythagorean theorem. So I'm going to do 5 squared plus x squared is equal to 13 squared. I know that 5 squared is 25 plus x squared is equal to, I believe that that's 169, but let me just check. At 169. So that means that x squared is 169 minus 25, which is 144. So x is 12. That means that the opposite side of this triangle is 12. That means when I go up here and I need to know what the sine of y is, the sine is opposite over adjacent, so 12/13. And that's it. Okay, so cosine of x plus y, you write out what the equation is by taking a look at your reference sheet, plug in all the missing parts that you need, and then just go right through and do the math. So let me see here, a different color. So 4 times 5 is 20. Divided by 5 times 13, which is 65, minus 3 times 12 is 36, over 65. So this is a negative 16 over 65. And that is what cosine of A plus B is equal to. This kind of makes sense actually, because it's telling us that both those angles, x and y, are positive acute angles, so they're both in the first quadrant, so they're both between 0 and 90. So if we add them up, most likely our answer of adding those two together would be in the second quadrant, and you know that cosine is negative in the second quadrant, so it kind of makes sense that the cosine of adding those two together is going to be negative. Alrighty. You're going to see questions like this, and you're going to see the matching questions on the test, okay? Text me if you would like me to do more questions like that, but honestly I think that as long as you draw out 2 triangles and keep track of what values stay with the x and what values stay with the y, then it's really not that difficult of a problem, okay? So this is homework number 242, 246. This is number 93. Okay? Only 2 more homework assignments for this whole chapter, and then that's it. So let's just keep on moving. Alright. Double and half angles. And what I mean by double and half angles are this. Like sine of a double angle would be sine of 2 theta, or if that theta is like 30 degrees, it'd be finding the sine of 60 degrees. And half angles are sine of theta divided by 2. So whenever you're taking your regents and you see 2 theta, it should be like neon lights. Ding, 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 ding. You should be thinking double angle, double angle, double angle. Whenever you see theta over 2, you should be thinking half angle, half angle, half angle. Okay? It always, the 2 and the 1/2, they have to be right next to the theta, okay? Don't get confused about what we were doing with graphing where there's a 2 out front. That's not what I mean by a double angle. Double angle means that it's right next to the angle, right next to the theta. Okay, so this is not the same thing as this. All right. So let's just do like a quick example yet again to show you why this is important. Actually, before I even go on, this is yet again another one of the sections that you have on your reference sheet. So this is your whole reference sheet. We just finished talking about sum of two angles and difference of two angles. Now we're over here onto the other side, the right hand side, and you can see functions of the double angle and functions of the half angle. So sine of 2a or 2 theta, and then it gives you what the equation is. Cosine has 3 different equations that we can use, and I'm going to show you. They're all equal to the same thing. So you can theoretically use whichever one that you want in an equation, but sometimes it makes more sense to use the one with only cosine or the one with only sine, and I'm going to show you questions like that. For tangent of the sum of two angles, difference of two angles, double angle, half angle, we rarely ever see tangent being used in a question just because it's a fraction for all of these. It's kind of just more annoying than the others. 90% chance is that you will not see tangent in these scenarios on your Regents exam. So don't even worry about it unless there's one little question, okay? So I'm going to put this back over here, and this time we're going to be focusing on the right hand side of your reference sheet, which is double angle and half angle. So let me just show you an example of this really quick. Sine of 30 degrees. That is on your magic table. I already made that for you about a half an hour ago. Sine of 30 degrees is 1/2. Sine of 60 degrees is radical 3/2. So this is what most people think. They think that, you know, in order to find the sine of 2 theta, all you do is take 2 times the sine of theta. That's what they think that it should be. So let's see if that actually works. Does sine of 60 degrees, or radical 3/2, is that the same thing as 2 times sine of 30 degrees? And it's not, because radical 3/2 is clearly not equal to 1. So yet again, it's another scenario where what we think should be the case actually is not the case. And that's why we have these formulas over here. Same thing goes for the half angle. Okay? I'm going to actually stop this video right now and then start a whole brand new one.